Okay, so Leetcode 740, delete and un. I hope you have gone through the problem statement by yourself, but if you haven't got it, okay, let's just make it simple to understand. Let's assume an array of this one, this elements are 1, then 1, then 1, then 2, then 4, then 5, 5, okay, 5, and 6. So now if I take 1, then I have to remove 2 because adjacents are not allowed. I mean, if I take 1, then 1 plus 1 and 1 minus 1 has to be discarded, right? So if I take 1, then I shouldn't be having 2 in my answer. So if I take 1, then how the maximum earn I can get is how many times 1 occurs, that is 3. 1 into 3 plus I cannot take 2, but I can take 4. But if I take 4, I won't be having 5, right? So if I take 4, the count of 4 is 1. I cannot have 5, but I can have 6. That is 6 into 1, and this will give us 3, 4 is 13. But then another way can be, let's take 1 instead of 4. Let's take 5. This is 5 into 2. What the heck? But and if I take 5, I won't be having 4 and 6. So this is the last, right? So there is 18. So maximum is 18. So the answer will be 18. So this is all about the question. Let us discuss the approach, solution. To solve this, we have look. It is a dynamic programming problem. But even before dynamic programming, we have to basically we have to maintain a map, right? So let us make a map. Let us make a map first. And the elements are this 1, 2, 4, 5, and 6. The frequency of 1 is 3, frequency of 2 is 1, 4 is 1, 5 is 3, 6 is 1. And by using this map, we have to create a vector, because look, this is an original vector that is given, but here you can see the redundant elements. 1 comes 3 times, 5 comes 3 times, so we have to remove duplicated elements, right? So for this, make another vector using this map, and the element will be key of a map, right? So 1, 2, 3, 4, 5, and 6, right? Okay. Keep it 6, and let's call it ELE. The vector name of the vector is ELE, and now let's create a DP. Let's create a DP. The DP of the size the size of the DP will be equal to the size of this ELE vector. So this is like this. Now if you observe carefully, okay, let's mark the index first. 4, 5. So when I'm at index 0, the maximum on the using index 0, there is 1 into 3, that is 3. We have no, right now we have no choice because there is only one element. When I'm at index 2, I'll check that either this element is adjacent to this or not. If it is, then either I can take 2 or I can take 1. If I take 1, then I have to discard 2, right? So what is the arn basically? The arn, if the arn is nothing but here, right? Arn is equals to ELE of I refers to the current index, into map, let's call it M map of ELE of 1, right? So this 2 into 1 is 2, and the previous calculated answer is 3. So either I can take 3, I mean, we have to take maximum, right? In the end we gotta find maximum, so we'll keep track of maximum. If I take 2, then the arn up to 2 is 2, will be 2, but if I take 1, the arn up to 2 will be 3. So maximum is 3, so we will take 3. When there is no 4, I guess. Fine, there was no 4. No issue. When I have an index 2, 3 and 4. So when I'm at index, okay, I just remove this, index 2. When I'm at index 2, this is 2, right? Index 2, I'll check if this element is adjacent to the previous one or not. If it is, then same condition, I have to check the maximum, which one is maximum, this one or this one. So right now it is not adjacent, so what we can do is take the current arn, that is 4, plus the previous one, that is 3, so 7. So when I'm at index 5, then I have to make a decision again. That is, either I can take 5 or I can take 4. If I take 4, then the arn up to 4 is 7, but if I take 5, the arn is 5 into 3 is 15. But look, I cannot take 4, but I can take the arn up to 2. I can take the arn up to that is collected till now is 3, up to 2 is 3, and my current arn is 15, so I can take 3 plus 15, so there is 18, right? Now if I take 6, then I have to check again. If I when I'm at index 4, I have to check again, is adjacent or not. So it is adjacent, then I'll take the maximum. So because the current arn by using 6 only 6, and only 5 using 5 is only 18, right? So in the end, the last element of the vector, I mean the DP, will be containing our answer, right? So better understanding, just dive into code directly. Put the right code here. Oh, so we need a map first. Map of intent. Then let's call it map. Let's just initialize the map. If you want map of number 5. plus plus. So now make an iterator for the map. Iterator it create vector ELE that I've discussed for it equals map dot begin it equals map dot end it plus plus and ELE dot pushback it error first. So basically I'm doing this step. Key of the map is basically element of the ELE that I've discussed earlier. So now let's create a dp dp of in dp vector of in dp and ELE dot size. We can hardcode previous two values, I mean for element 0 and the element 1, because see when I'm at index 0 I have no choice, right? There is only one element, that is dp of 0 is 3. When I'm at index 1 there is only one element, that is before 1, index 1. So we can hardcode, right, for these two values. dp of 0 will be nothing but element of 0 into map of ELE of 0, and if dp of 1 is equals to it's not dp, it should be ELE of 1. I'm basically checking that the index 1 is adjacent to the previous index 0 or not. That is what I'm doing here. What the heck is this? Okay. Else, so if it is, then I'll take the maximum one, of course, max of dp of 0 or ELE 1 into map of ELE of 1. Either way I can add both the previous, which is to my answer 0, not really, there is dp of 0 plus ELE of 1 into map. Okay, I'll just copy this stuff. So this is done. Now we can apply the logic. Not nums, it is ELE equals size. Either way, I have to calculate current earn I can get, that is ELE of I into map of ELE of I. Now I have to check if this is adjacent to the previous one or not. If it is equals to ELE of I minus 1 plus 1. So So look, when if I take 5, I cannot take 4, but I can take values up to 3, up to calculated up to 2, right? So index, so if it is I, then I minus 2, I can take the values of I minus 2, right? So I cannot take I minus 1 if it is equals, but I can take I minus 2 even it is equals or not equals. So let's call it earn before, earn previous, earn prev, that is dp of I minus 2. Now I can basically take the maximum one, max of, either I can continue the previous value dp of I minus 1, either way I can just take the current earn plus earn previous earn, and if it is not equals, I mean if it is not adjacent, then we can just add it the previous one too, I minus 1 dp of I minus 1 plus r, and in the end I'll just return dp of that. Code is almost done. Let's handle test cases, sorry, some edge cases. So look, if an array is given, if it is given only one element, or let's say it is given 3 element but same, so either way size of the ELE is 1, right? So we have to check this before we create dp. So if ELE dot size equals to 1, then we can just simply return ELE of 0 into map of ELE of 0. So we can, I guess we are done. Let's just run it. I hope there shouldn't be any error. Okay. Map. Okay. But it goes for where it goes wrong. dp of I plus p dp of r. This seems looks good. Element of y. Accept. What's wrong? Really? I minus 2, that's fine. dp of y, max of dp of I minus 1, that's perfect. Equals, something is wrong up here, I guess. It of nums, map of nums of I plus plus. Okay, it is not ELE, it is DPA, right? It is DPA now, I guess it should work fine. Submit, and it should get accepted as expected.